All right, good day. Hope that you're doing good. Now, in this video, I just wanted us to look into acids and bases, and our main focus is going to be on question 7. Now, question 7, there is a question based on hydrolysis as well as pH calculations, right? Which are the two things in which we're going to cover in today's lesson. Now, first, 7.1 says, according to the balanced equation below, a dilute solution of hydrochloric acid is used in titration against ammonia solution. Now, 7.1.1 wants us to define hydrolysis. Now, what is hydrolysis? Now, hydrolysis is your reaction of salt with water that changes the pH of the solution. The pH. Now, hydrolysis is your reaction of salt with water that changes the pH of the solution, right? Now, how does that happen? Now, first, let me explain. With regards to hydrolysis, the kind of questions that you could get or the kind of reactions that you would get an acid reacted with a base. Now, we know that always when we react an acid with a base, we always get our products as salt and water. Now, hydrolysis is the reaction of this salt, right, with water, and as a result, that reaction will change the pH of the solution, right? Now, during hydrolysis, either H3O ions are going to be formed. Now, it means when H3O ions are formed, the pH of the solution would reduce. Because why? These ions reduces the pH, or it makes your solution to be more acidic. Or OH ions are going to be formed, which these ions, they increase your pH, right? Now, when hydrolysis occurs as a result of this salt reacting with water, either H3O ions or OH ions are going to be formed. And we're seeing that these ions, which were formed as a result of hydrolysis, right, they would change the pH of the solution. Right. Now, how would hydrolysis occur, or what are the requirements for your hydrolysis to occur? Now, hydrolysis would only occur if your salt is from a weak acid or a weak base. Meaning that you need to look at the conjugate base pair or the conjugate acid pair of your salt and identify whether is it from a weak acid or a weak base. And if that's the case, hydrolysis would occur, meaning that if your salt is from a strong base or a strong acid, hydrolysis would not occur in that instance, right? Now, let us try and analyze the given reaction that we have here. Now, in this reaction, we have hydrochloric acid, which is reacted with NH3, right? And they said, as a result, what would be formed? It's NH4 as well as your chlorine. But we said this is our salt, by the way, and water would also be a product. Now, why is that? First, your hydrochloric acid, it's an acid, or rather, it's a strong acid. This is a strong acid. Now, what about your NH3? Your NH3 is a base, but this it's a weak base. So this is a weak base. Right? Now, as a result, we need to analyze this salt, right over here. We need to analyze this salt, right? And we're going to break it down. So we have NH4. We also have chlorine. Now, this is our salt, and we need to identify the respective conjugate base or acid pair. Now, first, let us take a look at our NH4. Now, our NH4 between hydrochloric acid and NH3, where does it come from, or what is its conjugate pair? The conjugate pair of NH4, in this case, it will be NH3, right? Now, what about chlorine? Its conjugate pair, it would be the hydrochloric acid. Now, the next question you need to ask yourself is whether is NH3 a weak acid or a weak base? In this case, we said this is a weak base. And then we said hydrochloric acid is a strong acid, right? Now, as a result, right, in this instance, because this NH4 is from a weak base, in this case, hydrolysis would occur. Now, what about the second scenario whereby your chlorine is from a strong acid? In this case, hydrolysis would not occur. All right, now this is the first step you need to go about. Now we know that hydrolysis would only occur in this instance here. All right, now let me just clear everything up so that we could perform the actual hydrolysis reaction. Now we said hydrolysis would occur on your salt, which is NH4. Now, first we define what is hydrolysis. We said hydrolysis is this reaction of your salt and water, and as a result, this would change the pH of the solution. So this is our salt whereby hydrolysis would occur. right? Now, we need to write down the balanced chemical reaction for this. So let me notify you something about weak substances, to be specific, weak acids and weak bases. So generally your weak acid as well as your weak base, they are very bad at reacting. Now, as a result, whenever they get a chance, they're going to try to go back to their original form. Now, this is a base, or rather this is from a weak base, right? And we say this is going to try to go back to its original form, which is NH3, right? So as a result, this is going to be NH3. Now, as a result, it would lose one hydrogen atom, and that hydrogen atom, it would be bonded with your water, and H3O ions would be formed. Right. Now, this is our balanced chemical equation, right? Our reaction of our salt NH4 with water to form NH3, H3O. Now, because H3O ions are formed, right? And remember, what do these H3O ions do? They reduce your pH. This simply means that the final solution in this case, it will be acidic. Why? Because H3O ions are formed, right? Now, to answer the preceding question, write down the balanced chemical equation and explain the answer. Now, this is our balanced chemical equation. And we say, okay, titration would occur in this NH4 because this is from a weak base, right? And as a result, it would be reacted with water. And this reaction would change the pH of the solution by forming the H3O ions, right? Now, this is our balanced chemical equation. Now, moving on to the second question, which is 7.2. 7.2 is a titration question, right? So my main focus here for this question, I just want to answer this pH calculation question, right? But then I will just answer these few theory questions with regards to your 7.2.1. Hydrochloric acid is a strong acid. Why is that? Because it ionizes completely in water to form H3O ions. Now, okay, let me move on to the 7.2.6, right? First, I want to write down the chemical equation for it, or rather it's still the same. Now, let me try and interpret the information from this. So they say, okay, from the above titration, right, 25 centimeter cubed, right? Okay, 25 centimeter cubed of 0.1 mole per decimeter cubed of NH3. So they gave us the volume here, but you know your volume should always be in decimeter cubed. So basically, our V here, we're going to say 25 divided by 1,000 to get decimeter cubed. And as a result, the volume for NH3 would be 0.025. Right. What else are we given? They're given the concentration, C, as 0.1. Now, they say it's titrated against, okay? Now we're given information with regards to our hydrochloric acid. It's titrated against 40 centimeter cubed of hydrochloric acid. Now, remember, also this should be in decimeter cubed. So we need to divide this 40 by 1,000. And as a result, our volume for this hydrochloric acid would be 0.04. Now, this question says, calculate the pH of the final solution if the concentration of the hydrochloric acid, now in this case, they gave us the concentration of this, it was 0.1. Now, how do you go about calculating pH in this scenario? First, you need to find your number of moles. Step, right? You need to find your number of moles, right? And in this case, you're going to make use of that formula C is equals to N over V. Basically, your number of moles is equals to concentration multiplied by your volume, right? In this case, our number of moles, it will be 0.1 multiplied by 0.04, and our number of moles, my number of moles, it will be 0.004. Now, my number of moles for my NH3, they would be equals to 0.0025. All right. Now, I've calculated my number of moles. Now, remember, to calculate your number of moles is the concentration multiplied by your volume. Now, step one, you need to find what's in access, right? So basically, we need the access reagent. Now, remember, what is your access reagent? Your access reagent, it would be what would be left after this reaction has taken place. Now, in this case, if let's say, for example, NH3 would be our access. After the reaction has taken place, NH3, right, it would be floating inside water, meaning that NH3 would be left, and this NH3 which would be left, it would be floating inside water, right? And as a result, this would enable us to find, because remember, to calculate your pH, you must use this formula whereby we say pH is equals to negative log concentration of H3O. Right. Now, Here, we don't have any information with regards to H3O. So how can we find the information regarding H3O? Only if we react our access reagent with water, because why? Your access reagent would be left after the reaction has taken place and it will be floating inside water. Now, let us go about doing that. So first, I would say, right, if I have ACl, right, if I have hydrochloric acid. Now, if I have hydrochloric acid, I will compare it to my NH3, right? So it's ACl is to NH3. Now, what is the ratio between these two? Is 1:1, right? So if I have 0,004 moles of HCl, how many number of moles of NH3 would I need, right? Now, here I will cross multiply, and as a result, I would need 0,004 moles of NH3, right? These are NH3 moles needed. Now, these are the number of moles you need to use all this 0,04, right? But how many number of moles with regards to NH3 do we have? So on NH3, we only have 0,0025. Now, compare the two values. You need 0,004, but you only have 0,0025. It means that NH3 has insufficient number of moles, right? Meaning that you need 0,04, but you have 0,025, which is less. As a result, this would be your limiting reactant. Now, that means that what? Our hydrochloric acid would be the access, right? Now, we have identified our access reagent, right? Let me just erase here. And we are saying that, all right, hydrochloric acid will be our access reagent. Now, what does this mean? This simply means that after the reaction has taken place, your hydrochloric acid would be what would be left. So your hydrochloric acid is the reactant that would be left, HCl, and this HCl, it will be floating inside water, right? Now, second step, we need to find the number of moles that are in access, right? 2, number of moles in access. Basically, how many number of moles are left for our HCl after the reaction has taken place. Now, let me go about doing that. So let me say if I have NH3, so I'm going to do the same thing I did. So if I have NH3, remember, if I have NH3, right, the ratio between NH3 and HCl is still 1:1. So if I have 0,025 moles of NH3, how many number of moles of HCl will I need? It's the same. Cross multiply, you would need 0,025. So these are the number of moles for hydrochloric acid, right, HCl, that will be used in order to react all of this NH3 0,025 moles, right? So basically here, to find the number of moles in access, I would say, okay, for my hydrochloric acid, I have 0,004, and I only used 0,0025. So as a result, the number of moles that will be in access, they're going to be equals to 0,0015. Now, these are the number of moles in access, meaning that these are the number of moles of this hydrochloric acid that's floating inside water, which are left, right? Now, this would enable us to calculate our pH. Let me just erase there. Now, we're saying after the reaction has taken place, hydrochloric acid, it will be floating inside water. Now, here you are reacting what? An acid with water, and this is what we call ionization. Now, remember, acids are hydrogen donators, meaning that they're going to donate their hydrogen atom. As a result, the balanced chemical equation for this is chlorine, right, minus plus H3O. Because why? Acids form these H3O ions that reduces the pH of the solution. Now, this is the balanced chemical equation for what I've just explained here when I said your hydrochloric acid would be floating inside water after the reaction has taken place. Now, as a result, what information do we have? I have the number of moles that were left with regards to this hydrochloric acid, basically our access number of moles, which was 0,0015, right? And what else do I have? Let me see. So I need, remember, to calculate my pH, right? So let me just erase here. Now remember, to calculate my pH, right, I would need to make use of this formula whereby it says pH is equals to minus log the concentration of H3O. Right? I need the concentration of this. This is what I'm looking for. Right? Now, using ratios, right, I can find the number of moles for H3O. How? Now, the ratio of your hydrochloric acid and your H3O, it's basically 1:1. So meaning that they would both have the same number of moles, meaning that the number of moles for this, my number of moles for this H3O would still be 0,0015, making use of ratios, right? Now, the only thing that would enable me to find the concentration is if I find the volume, because remember this formula, C is equals to N over V. We need to find the volume. Now, what would be your volume? Now, remember before, right? Before, they said, okay, the volume of this hydrochloric acid, we have calculated it, right? Basically, now remember we said before, the volume of this, which is 40 centimeter cubed, of which we converted to decimeter cubed, is 0,04. And this is the volume of my hydrochloric acid. And what about my NH3 volume? This was 25 centimeter cubed, converted into decimeter cubed. The volume here, it was 0,025. Now remember, this is after the reaction has taken place. Now, always the volume for your products, it would be the addition of your volumes of your reactants. Because why? Your volume represents what's in the container, right? Hence, we say the volume of your product, all of them, it would be the addition of the volume of your reactants. In this case, the volume for our products, right? For all our products, it will be the 0,04 plus the 0,025. So if I add the two, 0,04 plus 0,025, I would get 0,065. This is the volume for all my products, meaning that the volume for this NH4Cl, it's 0,065. The volume for this chlorine here, it's 0,065, meaning that also the volume for this H3O, it's 0,065. Now, I found my volume here, right? I can find the concentration, which is what I was looking for. Now, remember, making use of the C is equals to N over V, right? So I'm looking for the concentration of H3O. In this case, my number of moles is 0,0015 divided by my volume of 0,065. As a result, the concentration of H3O, it will be equals to, now the concentration of my H3O, remember you don't round off up until you get to your final answer. It's 3/130. Now, going back to my pH formula, whereby I said pH is equals to negative log the concentration of H3O. In this case, I will substitute this concentration I got into this formula. Now, when I punch this into my calculator, my pH would be 1,64, rounding it off to 2 decimal places. Now, this makes sense. Why? Because hydrochloric acid, or our HCl in this case, it's a very strong acid. And we said NH3, it's a weak base, right? And if my hydrochloric acid, which is a strong acid, it would be in excess, meaning that it would be left after the reaction has taken place, and as a result, it will be floating in water. I would expect my pH to be less than 7 or to be acidic, right? Why? Because my hydrochloric acid is an excess, and hydrochloric acid is a strong acid. Hence, the pH of my final solution would be acidic, right? Now, that will be all for this question. If ever you have any questions, always feel free to reach out. Thanks.